students, today I would like to explain one more new topic. Let us see radioactivity. Henry Becquerel in 1896 observed that some substances were emitting some form of radiations. Radioactivity is a phenomena of spontaneous emission of radiations from the nucleus of certain elements. These radiations were called Becquerel rays. The substances which emit these radiations are known as radioactive substances. For example, uranium, thorium, cesium, radium, polonium, strontium, etc. are radioactive substances. Rutherford conducted an experiment and identified the nuclear radiations as alpha rays, beta rays, and gamma rays. Now let us see about radioactive decay. Atoms of heavy elements like uranium, thorium, polonium, and radium, etc., are constantly breaking up into fresh radioactive atoms with the emission of alpha, beta, and gamma rays from their nuclei. In the process, the original atom, we are going to call that original atom as parent atom, disappears and gives rise to a new atom. We are going to call that new atom as a daughter atom. These new atoms are also in general radioactive and hence spontaneously breaking up in their turn, thereby leading to a long chain of different radioactive elements in the form of a series until an inactive element means usually lead is reached. This spontaneous breaking up of nucleus is known as radioactive disintegration or radioactive decay. We have three types of radioactive decay: alpha decay, beta decay, and gamma decay. Now let us see an important, there is very important topic, radioactive decay law. The rate of decay or the rate of disintegration of radioactive atoms is directly proportional to the number of atoms present at that instant. Or we can define in another way also. It states that the number of atoms that disintegrate per second is directly proportional to the number of atoms remain unchanged at that instant. If n is the number of atoms present in a radioactive element at any time t, dn is the number of atoms that disintegrate in a short interval of time dt, then dn by dt gives the rate of disintegration. According to decay law, we have dn by dt is directly proportional to n, or dn by dt is equal to minus lambda n, where lambda is the constant of proportionality known as disintegration constant or decay constant or radioactive constant. It depends upon nature of the radioactive substance, and negative sign implies that n is increasing with time. Now let us see one more important topic. It is also very, very important. Show that n is equal to n0 e to the power of minus lambda t. Just now we have seen decay law. According to decay law, we have dn by dt is equal to minus lambda n, or dn by n is equal to minus lambda into dt. Integrate on both sides, that is integration of dn by n is equal to integration of minus lambda dt. Then we get log n base e is equal to minus lambda t plus c. I am going to call this equation as 1, where c is a constant of integration. When t is equal to 0, n is equal to n0. That is, when time t is equal to 0, that is initial number of atoms, n is equal to n0. That means initial number of atoms, that is initial number of atoms is equal to n0, and after time t the number of atoms is equal to n. That means starting number of atoms is equal to n0, after time t number of atoms is equal to n. Therefore equation 1 becomes log n naught base e is equal to 0 plus c, or c is equal to log e n naught. Substitute the value of c in equation 1, then it can be written as log n is equal to minus lambda t plus log n naught base e. Therefore log n by n naught is equal to minus lambda t, or n by n naught is equal to e to the power of minus lambda t. Finally we get n is equal to n0 e to the power of minus lambda t. The above equation is an exponential equation. This implies that the number of radioactive atoms decreases rapidly at first and more slowly as time goes on. Hence, theoretically speaking, for the radioactive element to disappear completely, an infinite time is required. Just if I draw a graph between n and t and log n and log t, we get two curves. That is actually, one is a curve that is exponential curve, and in second graph I am getting a straight line. Slope of that straight line is equal to minus lambda, because I am going to compare log n is equal to log n naught minus lambda t with equation of a straight line, that is y is equal to mx plus c. Then we get slope is equal to minus lambda. Okay.